Let's talk about the communications in microservices. Well, generally, we have two ways of communication: synchronous and asynchronous communication. Synchronous communication is a real time communication where we exchange information with others and immediately or after some time we get the response. That's a synchronous communication. It's a two-way communication. For example, we are in a live chat, we are on a video call, we are talking someone with on a phone. So that's a synchronous communication. The protocols for synchronous communications are SOAP, REST, GRPC, JSON, or PC. So we can use these for implementing the synchronous communication. When we can use the synchronous communication when the response is necessary but not the time, because we wait for the response. The response is necessary. We are placing an order. First we check the item or the inventory. We have an inventory microservice. So we wait for the inventory service to give us the response about the particular product that we are going to place the order. So the response is necessary there, not the time. These are the examples: video calls, phone call, live chat. Asynchronous communication, it means the interaction without real-time conversation. The replies can be delayed, or they cannot, or there could be a no reply. So the client makes a call to the server and the server will process the request and complete it. So the request typically is sent to a queue. So the example is like we get the notification by email when we place the order on Amazon or any other applications. There could be an API associated with for notifying the user. So once the order is placed, uh, the application would send an event, notify user, something like that, and it will not wait for the response from the notification API. It will just send the event and comes back. It's up to the notification API or the microservice how the notification is going to be taken. So that's asynchronous communication. We can use the Redis or the Kafka for the asynchronous communication implementation. These are the pub/sub or the event-driven approaches, where one microservice is raising an event or publishing an event or a message. The other services, they are the consumers, they are the receivers, they are the subscribers. Once the event is raised, they will automatically listen to the event and they can work on it accordingly. When can we use it? When the immediate response is not required. These are the examples: emails, WhatsApp, social media. Now let's talk about the ways microservices can communicate with each other. There are a number of ways. The first one is HTTP RESTful APIs. So this is the standard approach. We have an API that has a URL, right? So we can expose that URL to the other microservices. They can make the request like get, put, post, delete. And this is how the communication would happen in between the microservices. The other one is messaging queue. Microservices can communicate asynchronously using messaging queue such as RabbitMQ, Apache Kafka, and Amazon SQS. For asynchronous communication, we can use them. Like we discussed, it's a event-driven approach, the pub/sub models, so we can use that for the asynchronous communication. This RESTful API, this is the synchronous communication. You already have seen it. When we make the request to any API, we wait for the response from that API. So that's the synchronous communication. The next one is event-driven architecture. Again, when an event occurs in one microservice, the other microservices, they are the subscriber to those events. When they listen to the event, they will work on it accordingly. The next one is GRPC. It's a Google Remote Procedure Call. This allows microservices to communicate efficiently using protocol buffers for serialization and HTTP2 for transport. This is the fastest way of communication between the microservices. It can be asynchronous or the synchronous communication. We have to create the .proto file. We have to add the required information, the functions, the model, the response, or the parameters. This is the way of we can implement it. I'll definitely create a video on that. The service mesh, it's a dedicated infrastructure layer that facilitates communication between the microservices. So we have different microservices. We have to deploy it somewhere, right? Suppose we deploy on the Docker. So then when we deploy on the Docker, that for each microservice, we have to deploy the sidecar proxy as well. This will have the access to the host, the port number, or the service discovery, load balancing, cross-cutting concerns for each of the microservices. We can use Istio as an example for service mesh. Then next is direct database communication. In some cases, yeah, though it's not recommended, microservices may need to communicate directly with each other's database. However, this approach should be used cautiously. It can lead to tight coupling or the potential data consistency issue. So these are ways that the microservices can communicate with each other. So that's all for now. I'll see you in the next video. Bye bye.